In this video, I will go over the homework that follows the lecture 2.2 that's called Differentiating Logarithmic Functions, in which we'll learn how to find the derivative of a logarithmic function. And since we already know how to use the rules of differentiation, such as the linearity or product or quotient or the chain rule, we should be able to combine these new knowledge with the past knowledge as well. As always, I hope you already watched these lectures, as I will be referencing them and expecting you to have a basic understanding of the material. So let's start. Let's take a look at the homework. And the first question is to find the derivative. And before we begin, let me remind you that derivative of a natural logarithm function is 1 over x, and since x, according to the domain of ln x, x has to be positive, so this identity only makes sense when x is strictly positive. Now, when we have log of x base b and we're finding the derivative, we can simply use the change of base formula, and then the derivative of this will be x 1 over x ln b, and also it only makes sense when x is positive. Now that we know how to differentiate natural logarithmic function, we also know how to differentiate the composition of natural log with some other function. So by the chain rule, it will be 1 over g of x times g prime of x. And frequently we just write g prime in the denominator as a single ratio. When we have log of some function g base b, it's going to be similarly g prime of x over g of x, but we're also going to have ln of b in the denominator. Now, when we have a composition of g and ln x, it's going to be the derivative of g with ln x in it times 1 over x. And if we have g of log of x base b, it's going to be g prime log of x base b 1 over x ln b. So these are the rules, and let's start applying them. The first problem is f of x is equal to ln of x cubed plus 6x squared divided by negative 2x. Here we have to identify this function as a ratio. So to find the derivative of it, we need to figure out the derivative of each of the components. So u is equal to ln of x cubed plus 6 squared, and v is equal to negative 2x. So v prime is just negative 2. But to find the u prime, we're going to identify this as ln of g, where g is my polynomial. So derivative of this function will be g prime over g. So if g is x cubed plus 6x squared, then g prime will be 3x squared plus 12x. Now we have everything, and let's put it all together. So the derivative of this function will be u prime v minus u v prime over v squared, which is equal to u prime is 3x squared plus 12x divided by g, which is x cubed plus 6x squared, times v minus u v prime. Running out of space here, so it's going to be ln of x cubed. Let me bring this whole thing down. because we're going to divide everything by v squared, which is negative 2x squared. We have ln of x cubed, so finishing writing this out, plus 6x squared times negative 2. And this can be simplified. Oh, maybe we shouldn't bother. We can definitely take out a bunch of 2's, but other than that, it doesn't seem like it will simplify. So let me just copy the way it is, which is going to be painful, but it is what it is. The denominator is 4x squared, and the numerator is, we have first fraction 3x squared plus 12x divided by x cubed plus 6x squared times negative 2x minus, and we have negative 2, so minus minus, it's plus 2 ln of x cubed plus 6x squared. That's the answer. And we can reduce it by 2, right? So this whole 2 can come out. So it's going to be 2 over here. There's no 2 over here. And here we just have negative x, which I can just throw in here in the numerator. Oh, this negative x can be reduced, remember, with this. And what I'm doing here probably is unnecessary. Oh, and now this x can be reduced. Huh. Well, hopefully I didn't make any mistakes reducing things. Let's see. Got it. This looks like it's going to be a long homework, so buckle up. Let's continue. Number 2. And it could be very tempting for us to use the chain rule. And according to the chain rule, it's going to be the, so if we're going to call this g, it's going to be g prime over g. So my g is 7x cubed square root of 8x minus 4. And my g prime, now I have to differentiate this, so it's going to be 7 doing the product rule. So derivative of x cubed is 3x squared times square root of 8x minus 4. Plus, now we're going to do the 7x cubed times the derivative of square root of 8x minus 4, which is 1 over 2 square root of 8x minus 4. It's the chain rule, times the derivative of 8x minus 4, which is 8. And it could be very tempting to do this, but before we do this, let's simplify f, and let's separate that product into the sum of logs. So we're going to have ln of 7 plus ln of x cubed plus ln, and here I'm going to rewrite the radical as the power 1/2. And look what's going to happen here. ln of 7, we're going to use another property of logs and rewrite it like this. And now we can take the derivative. So derivative of this function, it's simply the derivative of this sum. But this sum is much easier to differentiate than the original function. So derivative of ln 7 is 0 because it's a constant. Derivative of 3 ln x, it's 3 times 1 over x. And derivative of 1/2 ln of 8x minus 4, it's 1/2 times 1 over 8x minus 4 times the derivative of 8x minus 4, which is 8. And we're done. this is the answer. Believe it or not, it's actually the same as the one we obtained on top. But you can clearly see it's in a much better form. And if you don't, I was going to plug it all in Desmos to show you, to graph both of these functions to show you that they're equivalent, but I don't want to type this one. Again, we're going to simplify this function. We're not going to try to do the chain rule. Simplifying this function, we're going to have ln 6 plus ln x plus ln of sine of 9x minus ln of 1 minus x. And we're going to find the derivative of this function by differentiating it one by one. So derivative of ln 6 is 0. Derivative of ln x is 1 over x. Derivative of ln something is 1 over that something times derivative of that something. But derivative of sine of 9x by the chain rule is cosine of 9x times 9. So we have that extra 9 over there. And here we have the same thing. So it's going to be derivative of 1 over 1 minus x times the derivative of 1 minus x, which is minus 1. That's it. So the final answer is 1 over x plus cotangent of 9x times 9 plus 1 over 1 minus x. So I'm simplifying as I'm entering it. Chain rule. So derivative of sine is cosine. And now just plug everything in. Times derivative of what's inside. So it's going to be times negative 4 times 1 over 4x minus 3 times derivative of what's inside, which is another 4. I'm going to take the negative 16 in the front. And I'm going to divide the whole thing by 4x minus 3. So if you're not comfortable with simplifying as you enter the answer, then don't do it. Enter it exactly the same way you have found it on paper, and let Newton check the work, or check the correctness of the answer. Here we have another logarithm, and before we start differentiating, I'm going to use the properties of logs, and we're going to rewrite this logarithmic function as ln of 4, and I'm going to actually simplify it right away. 4 ln of x, so this 4 came down, plus ln of sine of negative 7x minus ln of 3x minus 3. And we're going to differentiate this function by taking the derivative 1 by 1 of each of these logs. So derivative of ln 4 is 0. Derivative of 4 ln x, it's 4 over x. Derivative of ln of sine of negative 7x, it's sine of negative 7x times the derivative of sine of negative 7x, it's cosine of negative 7x times negative 7. Finally, we have 1 over 3x minus 3 times the derivative of 3x minus 3, which is 3. So let's enter the answer. 4 divided by x minus 7 cotangent of negative 7x minus 1 over x minus 1. And we can be fancy and take out this negative because cotangent is an odd function. But again, you don't have to if you don't feel comfortable. Another logarithmic function that can be simplified before differentiating it. So we have here 1/4 ln of the difference. So it's going to be 1/4 ln of x minus 2 minus ln of 5 minus 10x. And to differentiate this function, we're going to take out the 1/4 and differentiate this term by term. So it's going to be 1 over x minus 2 minus 1 over 5 minus 10x, and multiply by the derivative of 5 minus 10x, which is negative 10 in the numerator. So I'm going to leave 1/4 outside, but I am going to rewrite this one and reduce everything by 5 and flip the denominator. And that's the final answer. So here we have a product rule, which we are familiar with. So let's just find the derivative. We have derivative. So we have, let's not worry about this 2. This is my u, this is my v. So we're going to write negative 2. And now we have u prime. So it's negative 3x to the negative 4 times v, ln of x, plus 1 over x, plus u, which is x to the negative 3 times v prime. And v prime here, it's the derivative of logarithmic function, so we put the input in the denominator, and in the numerator we put the derivative of the whatever we just put in the denominator. So here's the final answer. We can distribute and simplify, but let's not worry about that. We're going to simplify this function. So we have, oh, actually, no, hold on. We don't have a radical inside of the logarithm, sorry. So here we just have a long chain rule. So derivative of f of x, it's going to be 1 over 2 radicals. But inside we put the inner function. Now we're going to multiply everything by the derivative of ln, which is the reciprocal of the input. But because it's a chain rule, we're going to multiply by the derivative of the input in the numerator. So negative 5 plus 4x to the negative 3. Let's see if we got it right. Let's see. Interesting. I think, I don't know what to think here. I'm pretty sure I got this right. So we have derivative of the radical function. It's 1/2 x to the negative 1/2 times derivative of ln, which is 1 over the input. Times the derivative of the input, which is negative 5 plus, oh, is it plus or minus? Oh no, I copied the problem wrong. Plus, there's a plus here, so there's a plus here, and therefore this is minus. This should be minus. Let me change the answer. Mistakes like this are inevitable. You just need to learn how to deal with it. And I will be very upset if I'm wrong again. No, I'm not. Right, so the worst mistake you can make is to copy your problem wrong. From step 1, you're basically setting yourself up for a failure. Although those mistakes are easy to fix, they are also not so easy to find. So kind of knowing this, it should be the first thing you check when you got your first attempt wrong, whether you copied your problem right or not. All right, let's try this one. It's just a product rule, and this is my u, this is my v. So u prime is negative 2 minus 6x to the negative 3 times v plus u times v prime. Well, the first thing I'm going to check is whether I copied the problem right. Derivative of u times v plus u. Oh my god, there's a typo here. Plus v prime times v prime. This is going to be a long homework. I have a feeling. Find the slope of the line tangent to the graph at x equals 3. So this is a good question because we can find this slope without differentiation by simply graphing this function. And we're looking at x equals 3. So at 3, let's find this point. 3 comma f of 3, so that's the point. And we can find the equation, we can find the y minus f of 3 is equal to some m x minus 3. So this is the equation of some line. We can play with the slope and try to figure out what's the slope of the tangent line, and it looks like it's 0.4. We can make it maybe smaller here, like maybe it's too rough. Maybe we can make the step 0.01. Now we have let's see, does it let me? No, what's going on here? So yeah, anyway, from this picture we learned that the slope should be around around 0.4, right? Now let's figure this out analytically. To find the slope means we have to find the derivative of the function at 3. And before we find the derivative, we are going to simplify this function. It's going to be log base 8 of negative 3x minus 2 minus log base 8 of x minus 5. And to find the derivative means we're going to differentiate this. So it's going to be negative 3x minus 2 times negative 3. But we also have ln of 8 in the denominator. And here similarly we have 1 over x minus 5 and ln of 8 in the denominator. And now evaluate this function, or derivative of this function at 3. Here's what we get. 3, I'll get rid of this negative. So we got, so this becomes just positive. 3 divided by 11 ln 8 minus 1 divided by negative 2 ln 8. So this is positive now. So we have 1 over ln 8. And here we have 3/11, so which is 6 over 22 plus 11 over 22. So 17 over 22 ln 8 is the answer. The first thing I'm going to do is check my intuition. So I'm going to plug it in here. And we see how this is kind of correct. But we can also check the work here and plug this in. Yep, we are right. So I know when I finish entering this, I will be marked correct. So learn how to check your work before entering the answer. That will give you that peace of mind without sending you down the rabbit hole. Similar problem. This was number 10. This is going to be 11. We have evaluating the derivative at 3, and the function is log base 4 of 5x cubed plus x minus 6. Derivative is, it's going to be 5x cubed plus x minus 6 ln of 4 in the denominator, and in the numerator it's going to be the derivative of this, so it's going to be 15x squared plus 1. Evaluating the derivative at 3 gives us 15 times 9 plus 1 divided by 5 times 27 plus 3 minus 6 ln of 4. You can either input it like this in Desmos, well, you can do it in Desmos, yes, but let me just be lazy here and see if Newton will accept this as my answer. I can do this math. I can subtract 6 from 3. Let's see if Newton accepts this. Yeah. Oh no. Well, it didn't accept the answer because of the formatting. It didn't accept it because it was wrong. And now it accepted it. I'm first going to simplify this, so I'm going to take out that radical. So as you know, cube root of something can be written as something to the power 1/3. So that power 1/3 can be taken outside of the log. And now the log of the quotient can be written as a difference of two logs. So we have log base 6 of 10 minus x minus log base 6 of negative 2x minus 5. Now to find the derivative, I'm going to take the constant outside and then differentiate one by one. Don't forget to multiply by the derivative of 10 minus x, which is negative 1. And here we have the same thing. And this is the answer. And we can get rid of these negatives to make it all positives. But other than that, there isn't much we can do there to simplify. We can take ln 6 out like this. So we have here negative 1 divided by 10 minus x minus 2 divided by 2x plus 5. We have another similar problem. First, we're going to simplify it. And we have 5 log base 6 of negative x plus log base 6 of cosine of 5x minus log base 6 of 6x minus 1. To find the derivative, using the chain rule here, so it's going to be derivative is a reciprocal with ln x in the denominator times the derivative of negative x, so it's negative 1. Same here, cosine 5x and ln 6 goes in the denominator. In the numerator goes the derivative of cosine, which is negative sine of 5x, times derivative of 5x, which is 5, and same here, 6x minus 1 ln 6 go in the denominator, and derivative of 6x minus 1, which is 6, goes in the numerator. So typing this answer, simplifying it as I'm typing it, so we have 5 over x ln 6 minus 5 tangent 5x divided by ln 6 minus 6 divided by 6x minus 1 ln 6. Next problem. We have a function, logarithmic function with base 9 of a product, and we have x minus 4 times 5x minus 2, and I'm actually going to rewrite it as a sum, and I'm going to apply the negative to x minus 4, so I'm going to write it as 4 minus x. And I'm going to split the log of the product into sum of the logs using the property. And differentiating this function is straightforward. It's just going to be 4 minus x in the denominator times ln 9 times the derivative of 4 minus x, which is minus 1, plus we have 5x minus 2 in the denominator times ln 9 times the derivative of 5x minus 2, which is 5. We can write the answer. We can factor out ln of 9, and here we have negative 1 over 4 minus x plus 5 divided by 5x minus 2. Oh, duh. We had to evaluate the function at 2. I forgot to read the question. So we have 1 over ln 9, and now evaluating it at 2 gives us this, plus this. So we have negative 1/2 plus 5/8, so matching the denominators, and we just get 1 over 8. So the final answer is hopefully. I just wasted one attempt on this, so I have to be very careful. So maybe I should use Desmos to check my work. My function is, actually, let's not delete this. My function was log base 9 of 4 minus x. 4 minus x times 5x minus 2. So my value was at 2, and we have 2, right? And we're gonna play with the slope. Looks like it's like very close to 0, right there. And we're just gonna plug it in. We have 1 over 8 ln 9, which is close to 0, so it makes sense. And just to make sure, we're going to plug it in. Yep, the answer is right. Now I feel comfortable submitting it. We have a similar problem. Oh no, we don't have to evaluate this one. So f of x is equal to log base 3. This looks like just a chain rule. So let's see. Derivative of this function is, since it's a logarithmic function, what's inside goes in the denominator along with ln of 3. And now we multiply by the derivative of secant in the numerator. So derivative of secant is secant tangent, but we plug in the inner function, and we multiply by the derivative of the inner function. So the final answer is, I guess secant cancels. So we just have 2 tangent of 2x divided by ln 3. Another problem. So if you wondered why did we learn the properties of logs, here's your answer. Without knowing properties of logs, you would be forced to use the composition of the log and the quotient rule, which isn't going to be pretty. If you know the properties of logs, you can simplify this immediately into this expression. This is not multiplication. It's log of cosine of 7x. So I should put parentheses here. Minus log base 2 of x minus 8. And now differentiating this function is easy term by term or piece by piece. So we're going to have 5 times 1 over 2x times derivative of 2x, which is 2. Which reduces to 1 to x. So if someone wonders why is derivative of this is 1 over x, it's actually easy to explain, because derivative of this must be the same as the derivative of this. But derivative of a constant is going to be 0. And I just realized I made a mistake because I didn't multiply by the ln of 2 in the denominator. Plus, so here we have cosine of 7x in the denominator along with ln of 2. Now multiply by the derivative of cosine, which is negative sine of 7x, but times the derivative of 7x according to the chain rule, which is 7. Finally, x minus 8 ln of 2 times derivative of x minus 8, which is 1. So let's write this answer. We have 5 divided by x ln 2 minus 7 tangent 7x divided by ln of 2 minus 1 over x minus 8 ln 2. And we have another similar problem, so let's just power through it. We have log base 3, and I don't mind copying problems. That actually gives me time to rest while I'm copying. So sometimes students trying to go too fast, and they're like, oh, I don't have time to copy this, let me just start doing the work. And then you just overstress your brain. So let's do this one. We have log of 3. So we have 4 log base 3 of negative x plus log base 3 of sine of 3x minus log base 3 of 10 minus 10x. And derivative of this is just negative x ln 3. We have 4 over here outside, and derivative of negative x is just negative 1. Plus, we have sine of 3x in the denominator along with ln 3 times the derivative of sine, which is cosine of 3x. By the chain rule, we also multiply by 3. Minus 10 minus 10x in the denominator along with ln 3 times the derivative of 10 minus 10x, which is negative 10. Let's take out 1 over ln 3. And what we have left is 4 over x plus 3 cotangent of 3x, and we have plus 1 over 1 minus x. Hopefully I didn't make any typos. Let's see. Yep, got it. And yeah, we actually did better job simplifying than Newton. So we finally finished. If you have any questions about finding derivatives of logarithmic functions or functions whose components are logarithmic, let me know.